Welcome to The Future Is, a podcast where we meet the people shaping what's next in business and life. I'm your host, Laura Kelleher, Honeywell's Chief Marketing Officer. The next time you travel to the airport and board a plane, think about the fuel that's powering your trip. Engineers and researchers focused on making the aviation industry more efficient are developing new and innovative ways to produce fuel for planes using materials like biomass, mustard seeds, and soon renewable energy. To discuss sustainable aviation fuel, or SAF for short, and the latest technologies available to produce it, I'm joined here today by Barry Glickman, Vice President and General Manager of Sustainable Technology Solutions here at Honeywell. Barry, great to have you here. Thanks for joining us today.
My pleasure. Thanks for having me.
So, sustainable aviation fuel, or SAF, is an exciting area of innovation. What progress has been made recently to help meet the growing demand for SAF?
So if you don't mind, maybe I'll take a step back and talk about why there is an increasing demand. So I think it really reflects, several factors. One is the increased awareness of the need for decarbonization across all sectors of the economy. And when you look at aviation, it accounts for roughly 1 billion tons of CO2 emissions per year. So it's not the largest source of CO2 emissions globally, but it is a meaningful source in the 2 to 3% of the total range. So I think there's really this global awareness now that we need to be looking for all the areas we can to quickly and meaningfully decarbonize. Governments are playing a significant part in that. So there's mandates now in the United States, there's mandates in the EU, there's targets in other parts of the world that are requiring sustainable aviation fuel to be blended with traditional fossil-based jet fuel as a way to increase the demand for SAF. And then on the supply side, technology providers like Honeywell are continuing to play a significant role in introducing new technologies that expand the available feedstocks for SAF, as well as advance those technologies to bring down the cost. And we're not quite to the point where SAF is at cost parity to fossil-based jet fuel, but the gap is shrinking. So all those things are coming together to not only increase the demand, but increase the supply of SAF.
Honeywell recently launched its e-fining technology, which produces eFuels. Tell us a little bit about how that works and what do people need to know about it?
Yeah, so there's various ways to produce SAF. So I'd say, just to give some history, Honeywell has been at this for over 20 years. And the first feedstock we looked at and introduced was what we call, and what the industry calls, fats, oils, and greases. So generally inedible oils, or you can think of things like French fry oil as the feedstock that you use through refining processes to convert it to SAF. The second technology Honeywell introduced was ethanol to jet. So it's the same ethanol that's used for gasoline blending can also be used as a feedstock to produce SAF. And then, Laura, as you pointed out, the most recent introduction is a technology called eFining, which is a way to take captured carbon dioxide and green hydrogen, convert that to methanol, and then convert the methanol to SAF. And the advantage to that is that the feedstocks for carbon dioxide that can be captured and for green hydrogen that can be produced with renewable energy is not anywhere near as constrained as the supply for fats, oils, and greases or ethanol. So it's a technology that not only has an opportunity to reduce the carbon intensity of aviation fuel by 85 to 90%, but it is a way to significantly increase the capacity of feedstocks to meet the demand for SAF.
Speaking of the fuels in general, what's the difference between an e-fuel and SAF?
So I'd say eFuels is a broad term that refers to electro or synthetic fuels. So it's anything which generally is a non-hydrocarbon or non-fossil fuel-based fuel gets the E classification. Now you can take E fuels and convert it into e-gasoline, e-diesel, or e-SAF. Sustainable aviation fuel, SAF, is the general category. eSAF would be a subset of SAF. So you can make SAF from all sorts of different feedstocks. So fog-based SAF is SAF, ethanol-based SAF is SAF. This specific type of captured carbon dioxide plus green hydrogen gets the eSAF designation because it is the least carbon intensive form of SAF. It's not zero carbon, but it's very close to zero.
We offer other technologies that enable SAF production. What are some of those, and why is it important to have different pathways?
So if you look at, again, taking a step back, if you look at the global demand for aviation fuel, it's between 6 and 7 million barrels per day. And the only way to meaningfully offset the use of fossil fuels to produce that much jet fuel is to have a wide range of feedstocks. So there's not going to be enough cooking oil in the world to produce 6 or 7 million barrels a day of SAF. So we need fats, oils, and greases. We need ethanol or other forms of alcohol. We need carbon dioxide and green hydrogen, so the e-fining path to SAF. And then ultimately, we're also going to need biomass as another pathway to SAF. And the way Honeywell looks at this is we need to have all of these technologies and offer all of them to the market as a way to provide enough capacity to offset as close to 100% of the fossil fuel that's used to make the 6 to 7 million barrels a day of jet fuel.
How do you see partnerships playing a role in this, in the continued advancement around sustainable aviation fuel?
So I'd say partnerships are essential, and they take many forms, and it won't be an exclusive list, but we need to have partnerships with various governmental agencies and entities. And the governments need to create the mechanism to place a value on the carbon abated. So if you look at what the United States has done through the Inflation Reduction Act, they've said if you reduce the amount of carbon in jet fuel by a certain amount, and there's a minimum requirement, then you qualify for a subsidy. And that's a way to create a price or a value for carbon. I think EU looks at it slightly differently, and they put a price on carbon and say, if you want to emit the carbon, there is a price associated with that. And it creates the same incentive to subsidize and create a market for lower carbon fuels. So governments as a partner is critical. Airlines as a partner are critical. And that includes airlines as well as the airframe manufacturers, as well as the jet engine manufacturers. So one of the great advantages of SAF is it works as a drop-in fuel in the existing infrastructure. So you can take a barrel of SAF and a barrel of jet fuel and blend it. It goes through the same infrastructure, the same storage facilities, the same trucks, into the same tanks, through the same jet engines. But we need to continue to partner with all of the people that consume SAF as we continue to increase the share of SAF in the total jet demand, and make sure we're all aligned on what the future of the industry looks like, and continue to coordinate across all of the different players.
So can you tell us, what's coming up next in this space, and what's needed to continue to scale these solutions?
So I think, again, just to recap what we have today. So we can make SAF today as Honeywell. We can make SAF with our operating partners with fats, oils, and greases through a technology we call eco-fining. We can make SAF through ethanol with a technology that we refer to as ethanol to jet. And we can make SAF through a combination of capturing carbon dioxide and green hydrogen through our e-fining. I think that the next technology that Honeywell will be introducing is how we take waste biomass products as a fourth pathway and are able to convert the biomass to a synthetic oil, upgrade that oil, and then convert that upgraded oil to another form of SAF. So I think that will be the next iteration of SAF. I think broadly, if you think of what's going to happen in aviation, beyond SAF, and Honeywell is also engaged in electrification and the use of hydrogen. So there are developments in the world of aviation relative to things like urban air mobility. And how do we use electricity to power small aircrafts for shorter distances and use that as a way to present the market with an alternative to using either SAF or traditional jet fuel for short haul trips. Similarly, there's a development around hydrogen, and Honeywell's involved with providing hydrogen to planes, and hydrogen either to power an APU as an auxiliary power unit to a plane, or to power the plane on the ground, or to power the various trucks that bring the luggage and the fuel to planes, or provide the air conditioning to the planes when they're at the gate. All of those things are in the future of aviation. So while obviously we're talking a lot about SAF, I want to say SAF is a part of the answer.
Yeah, it's fascinating how many technologies are being developed, now to support what's critically in front of us, right? The change that we all need to go through. One more question before we end our podcast here, Barry. Our podcast focuses on the future, but we like to end the episode by asking our guests to reflect on the past. So I want to ask you, when you were younger, what did you want to be when you grew up?
So the pre-8-year-old phase, I wanted to be a catcher for the San Francisco Giants. Of course, and unfortunately, I'd say it was the pre-8-year-old phase because my athletic ability, particularly in baseball, peaked somewhere between 7 and 8 years old. So sadly, by 8, it was clear I was not going to be a professional baseball player. My next career vision was to be a teacher. And I think like lots of children between 9 and older, I was inspired by a number of teachers. So I envisioned myself following in their footsteps, and that probably took me up until college, at which point I decided I wanted to be an elected official.
When did you decide you wanted to start developing sustainable aviation fuels to save the future?
In 20, no. So I got involved in renewable power and hydrogen in 1997. I wasn't aware of SAF probably for at least 20 to 25 years after that point.
Great. Well, thanks so much, Barry. Thanks for joining us today.